For a good while, the way that we have been able to identify ourselves as humans has been because we are intelligent. Homo sapiens is somewhat of the intelligent person, at least the person that can think. And eventually we get to sapiens sapiens, the person who can think about thinking, or who knows he knows, that kind of person. And of course, once we were able to use machines to replace many parts of our existence, it also became a matter of whether or not we can use machines to replace people. And those people could perhaps be able to think. And the domain of artificial intelligence kind of led us to thinking about the ways in which we can think about thinking in a machine way. 50 years ago, there was a conference for scientists who usually had nothing to say to each other. They came together to launch a scientific revolution, we are told. So in the 1950s, a bunch of people from all kinds of smart horizons put their brains together to start thinking about what it is to think or what it is to be intelligent. The invitees were from widely different fields, mathematics and psychology, biology and engineering, and some from the then new fields of linguistics and computer science. They convened for a month on the idyllic campus of Dartmouth College with the not so modest intention of starting a new area of research, a field in which their disparate disciplines would unite to solve some of the world's largest questions in science. What is thinking? What is intelligence? What is language? The mathematician John McCarthy coined a new term to describe the endeavor, quote unquote, artificial intelligence. Initially obscure, it has become so widespread that it is now a proper topic for movies and blogs. Its name emphasizes the artificial. It's really about the understanding intelligence sufficiently well to imitate it. McCarthy put the goal succinctly: to proceed on the basis of the conjecture that every aspect of learning or any other feature of intelligence can be so precisely described that a machine can be made to simulate it. To wit, if we can understand a brain, we can build one. And the people who started to work on the idea of artificial intelligence, especially this character here, McCarthy, who kind of coined the term, he invented programming languages such as Lisp that we have mentioned previously. He figured out new systems to use computer hardware for memory management as well, and try to essentially make sense of the way in which we could focus our computers into a way of thinking. And that way of thinking obviously passed through the aspect of language. Because we are people and we seem to think through language, the way that we could reproduce a language's thinking would be using some form of a language. And McCarthy is really focused on this aspect of finding language for computers that would essentially be reducible to a form of mathematics, essentially. That you could, using the symbols of mathematics, make sure that the language can be understood in a way that is, again, machine legible. In 1959, McCarthy tells us interesting work is being done in programming computers to solve problems which require a high degree of intelligence in humans. However, certain elementary verbal reasoning processes, so simple that they can be carried out by any non-feeble-minded human, have yet to be stimulated by machine programs. This paper will discuss programs to manipulate in a suitable formal language, most likely a part of the predicate calculus, common instrumental statements. The basic program will draw immediate conclusions from a list of premises. These conclusions will be either declarative or imperative sentences. When an imperative sentence is deduced, the program takes a corresponding action. These actions may include printing sentences, moving sentences on lists, reinitiating the basic deduction process on these lists. And in this sense here, this is a matter of looking for actions and reactions, or making sure that a computer can understand actions and reactions in a way that a certain thing is said and the computer understands it. The computer then takes the applicable action. So it is a matter of logic. It is a matter of understanding information, perhaps storing that information and using it in another way. So again, this is a pretty simple way in which you may be able to make your computer work. You use a sentence, the computer understands it, the computer does action based on that. And the McCarthy's goal at the time is what he calls a program with common sense. He's not necessarily looking for high-flying relationships of logic, not even deduction or anything of the sort. He's just looking at the ways in which a computer could understand language well enough to spout something out of it. And that in and of itself has not changed a whole lot in terms of how intelligence works. For example, this email that I received just this month from apparently a coworker, Emily Mineta, says available phone number, question my best regards with a Z, with her signature at the bottom. Now, this in and of itself is pretty much a textbook understanding of what a phishing message is. As you can see, the email address at the top is quite definitely not the email address of somebody at UVM. And so the chances that this is actually Emily Mineta sending me an email is pretty small. And obviously, the computer understood this because this was marked as spam. I think this was automatically marked as spam. I didn't do that. Anyway, the way in which this person was identified, of course, is by looking at the UVM website. So you have Emily Mineta, who is listed on our website, on the UVM website, as Professor, Associate Dean for Research and Graduate Education. And as you can see in her signature here, or in the email signature, is Professor, Associate Dean for Research and Graduate Education at the University of Vermont. So this has to be, right, the person who emailed me, because the data is there. The data was taken by something that looks like a machine and spouted again into a way that would hopefully make sense to me. Now, obviously, the part that says best regards is a little bit more complex here, especially if you take into consideration that Emily Mineta is a PhD, she is a doctor in linguistics, and therefore this is quite unregular spelling for a person who knows how English works. Now, of course, what we can assume from this is that the person who did write this email does not exactly know how English works, and that is kind of a giveaway for our purposes. But it kind of illustrates how these machines with common sense work, right? They take data that is available and output it to another format. And that is in itself the basic of an algorithm. Algorithm allow you to take linguistic input, so language, put that through a system that would create linguistic output. Now, the system itself is just a basis of classification of words. So there are keywords that can be used and recognized by the machine. And so there's the algorithm works in terms of those classifications of words, and the classification of data on the other hand. The process of an algorithm works as this: the linguistic input is put through, identified by the algorithm as a keyword, so trying to see what the conversation is about. The connection is made between the keyword and the larger amount of data out of that, and the classification work here is done by the computer through the computer. In other words, on the one hand, the computer tries to understand what I am doing from the intent. And on the other hand, the computer tries to understand and where this is going through the data, and then creates something, feedback and output that would essentially, hopefully, be understandable by me. Now, the way in which this works, like I said, hasn't really changed since the 50s. The most important thing that has changed for our purposes is the way in which the computer can learn how to do these things. And in other words, there are systems that are put in place for the way that these machines work to learn from their mistakes and to learn that some things are actually not working the way they should. So whether a keyword is not classified properly or the data is not organized properly, these things can be identified through essentially what is called a policy in the computer system that would, so when somebody is talking to a chatbot, for example, if you put the feedback that you did not receive as satisfactory customer service association, or if you did not understand what the other party was saying, then you are able to fix that from the algorithmic point of view, and you are able to adjust which keyword correspond to each data, so that hopefully the output would be satisfactory on the other hand. So this is how most algorithms work, by the way. We've mentioned algorithms a few times already in classroom discussions, and when somebody is talking about how the algorithm work, they are talking about how the data was made to be processed in this way that I'm showing here. So when you are getting specific ads on your social media, this is because an algorithm has seen the data that you sent them, that is your previous activity, processed that through their machine, and it outputs something that may or may not be what you wanted to see. And this is just a matter of training the algorithm to work in a certain way. Sometimes it works, sometimes it doesn't work. If you have very specific taste, it's much less likely to work. If you have not very specific taste, algorithms are working just fine for most purposes. But of course, the problem for us as humans is to make sense of this from an identity standpoint, because the process of thinking about things is not something that was invented by machines, and it's certainly not something that was easily reducible to a matter of logic. And of course, since the job has been lasting since the 1950s, you can tell that we have only made a very modest amount of headway in making machines think like us. Of course, yes, we have made a pretty big progress, all things considered, because those early 50s artificial intelligence programs were very basic. But to the extent that we have now much better machines, much better languages to make this work, it would seem like we would have achieved a slightly better result. But of course, that will depend on the amount of effort that is put into this work, and of course the economic benefits that are to be taken from this, because the main reason why currently anyone is trying to develop better models of artificial intelligence is to make money off of it. And of course, there are only very specific applications in which those models are going to be useful. That being said, in terms of making money, the way in which artificial intelligence has been used, especially, is for scams, like this one, for example. Imagine you wired hundreds of thousands of dollars somewhere based on a call from your boss, whose voice you recognized, only to find out that you were talking to a machine and the money is lost. One company executive doesn't have to imagine it happening. He and his company were victims of some experts is one of the first cases of voice mimicking software, a form of artificial intelligence, being used as a scam. So the idea here is that the artificial intelligence is able to change the linguistic data, and in this case, the sounds themselves, to sound like something else. In other words, that you can, using artificial intelligence, change the sound of your voice to sound like somebody completely different. And of course, there is money to be made from that. Now, because phones are only replicating somebody's voice in a very mechanical way already, it's a lot easier to fool somebody over the phone. In other words, if you had this same voice box in front of you, you would probably hear the slight differences in the sound that would let you know that this is not the same person. But this particular scam here is the same version as the one I got through email. That is somebody trying to reproduce somebody else's voice. And in this case, it works because the person on the receiving end of the scam did not recognize that this was not, in fact, their boss calling them. And using voice here as a way to change the format it's certainly one way that what makes artificial intelligence a lot trickier to recognize, because voice, and especially voice over the phone, like I said, is kind of a very modular thing. So if somebody has a cold or somebody is going through a tunnel or whatever, you don't expect that voice to be 100% legible, as opposed to an email, which, only really has one level of legibility. And whether it's an email that is written by the right person or the wrong person, you should be able to tell that pretty easily. Another format that has been used for artificial intelligence is images. And this particular image here, or this particular picture of a person, was created by AI. This is not an actual person. This is a person that was created from data about the physics of the human looks. So this particular artificial intelligence system saw millions and billions of pictures of people, and from that made sense of what a person's face looked like. And it output this particular picture here of a person that doesn't exist. Now, this system is once again based on an existing data set, and that data set is processed and output in a way that makes sense to me, the person looking at this picture. And if you stare at this picture long enough, you will see some things that are kind of odd about this person here, that of course they are not looking perfect because nobody does. And when you think about intelligence and you think about artificial intelligence, especially, people tend to think about perfection, of course. But this is not necessarily the case, considering that human beings are very weird to start with, and especially weird to a machine that doesn't know what a human looks like. So creating the picture of a person also means creating a picture that is not quite perfect. A picture of somebody that looks essentially imperfect means that this is a person that will look human, as opposed to a person that looks like a robot. And that in and of itself is not a new concern for anthropology. This series here of portraits are created by Francis Galton, the inventor of eugenics in the United States, and one of the people who try to make sense of how human looks affect their behavior. And one of the ways he started to do his works was through composite portraits. And yes, that is the same composite portrait that you still see today used by law enforcement to make sense of who attacked you in the TV. That's not nearly as common as it used to be, but it's still very commonly used. And here it is used by getting the data that was available to him, that is pictures of convicts, and superposing those different pictures of convicts to find kind of a middle ground of what a convict looks like. Now, of course, this is not designed to be a typology, of course. In other words, that these people are not supposed to look like criminals, as it's pointed out at the bottom here. Prevalent types of features among men convicted of larceny without violence. So these pictures are just indications as to who could be a criminal. This is just a way to facilitate, of course, the work of a law enforcement agent who sees a certain type of person in the street, and they can act upon it using this composite portrait. Now, for our purposes, of course, it's not entirely surprising that this kind of practice is derived 100% from racism. There's no question as to whether Galton was a racist, he said himself. But the idea here of using the kind of more or less expected features of what a human looks like, and especially connecting that to a specific kind of identity, is not new. It has just been perfected by the way AI works. And of course, today, this is one of the reasons why you hear that AI is creating racist models or creating things that are discriminating against certain groups of people, is because of the data that they were fed, and that data is usually collected by somebody and chosen by somebody, and that somebody may have some biases. Well, those biases end up being transcribed into how the computer works. This is not a function of AI itself. This is a function of people. And in the way that we are thinking about it today, and the way that we are thinking about imperfection, if a machine is able to spout racist nonsense, that does tell you something about how accurate those messages can be about the way that a machine works and how accurate they are about portraying human behavior. You feed them racist data, they output racist data. This is just the way that things work.